All right, good morning. It is 9 o'clock. We're going to get class started. So, welcome everybody. I hope you guys had a relaxing spring break. Unfortunate for us, the sun came this week, right? But a couple of things I want to just talk about really quickly. So, we're going to go over this warm up and we're going to be practicing congruence proofs today. Just remember, I'm going to, at the end of class, I'll talk about what's going to be happening Thursday and Friday. For classes. Your other teachers have probably talked about that. And then we'll talk about, at the end of class, we'll also talk about what's going to happen going forward, et cetera, okay? So let's get there. Let's get started. And then, as always, if you guys have questions or comments, you guys can always use chat, right, to send me a private message, or you can turn on your mic and ask a question as well, okay? So to get things started, this review here is a little bit of what we did before spring break, right? So just to like ramp us up into what we're doing, how many parts does a triangle have? So there's 6 parts, right? And in those 6 parts, there are 3 sides and there are 3 angles. Okay, so 6 parts, 3 sides, 3 angles. So, but then we talked about, okay, so if I wanted to prove triangles congruent, I'd have to show all 6 parts, and that's a lot of work. So there were 4 shortcuts that we talked about to prove triangles congruent. And so those are SSS, SAS, ASA, and AAS, right? So these are our 4. Now remember, in our proofs, this always comes first, right? We always want to prove triangles congruent first. Okay, so this is what we kind of worked on before spring break. Then, right before spring break, we talked about CPCTC. And besides being kind of fun to say, CPCTC, right, what does that mean? So CPCTC, if you just went by what it stands for, would be corresponding parts of congruent triangles are congruent. Okay, so corresponding parts of congruent triangles are congruent. But that is kind of weird and awkward to memorize. So what I would just think of CPC as being as if triangles are congruent, then, so if triangles are congruent, then all corresponding, so all corresponding parts are congruent. Okay, so some important things to note here. See how it starts with if triangles are congruent, right? So that's why CPCTC, we say it always comes second, right? So first, the triangles being congruent has to happen first. So if triangles are congruent, then all corresponding parts are congruent. So basically, what we talked about is if we can prove that triangles are congruent using one of these shortcuts, then the other, so right, there's only 3 parts here. The other 3 parts are then going to have to be congruent as well because they're incongruent shapes. Okay, so that's what's going on here with that. That's what we were talking about before break. Okay, and then like I said, today what we're going to do is just to get us caught up to what we were doing before break, we're just going to practice doing proofs today. And so again, I just want to remind people as we're going through this, if you have questions, please use chat to ask any question you want, or you can turn on your mic and ask a question as well. Okay. All right. So anybody have questions about this before we move on? If not, we're just going to jump right into, we're going to do a bunch of proofs today. How many proofs are we going to do? 1, 2, 3, 4, 5. We're going to do 5 proofs today. Okay, so let's just get right into it if no one has any questions. All right, so our first one we're going to start out with a bow tie problem. And all of these guys, I'm going to have you guys do these because these are all proofs that we've looked at before break. So remember, everything we do is open notes, and all the properties we've ever used, that was the first class of this trimester, right? So the very first class, we wrote down all the properties that we're going to need for proving triangles. So I'm going to start with a little bow tie. Remember, it's not drawn to scale, so you don't have to be a perfect bow tie drawer, okay? But I'm going to have a bow tie, and I'm going to label it A, B, C, D, E. And then I'm going to have some givens. Okay, I'm going to have two givens. I'm going to have that segment AC is congruent to segment EC. And my second one is going to be segment BC is going to be congruent to segment DC. Okay. And what we're going to do is we're going to prove that triangle ABC is congruent to triangle EDC. Okay, so that's the whole problem. And what I'm going to have you guys do is I'm going to have you guys try this out. So remember, we're going to have statements, and I can give you guys some hints, right? We're going to have statements, and we're going to have reasons. Right, so we're doing a little bit more formal this time. What we did before break was very informal, right? We just kind of wrote down the properties and talked about it. So what I can give you guys some hints, right? So first, remember, we only have 4 shortcuts. So SSS, SAS, ASA, and AAS, right? So it's got to be one of these 4. And then we should start with our givens, right? So what I'm going to do is I'm going to give you guys 3 minutes to work on this on your own. And then, and I don't expect everyone to get this 100% correct, but what we're going to try to do is figure out if we are getting stuck, where are we getting stuck? And if you're not getting stuck, then this is good practice to remembering the properties, okay? So let's take 3 minutes with that. And while we take 3 minutes, if you guys have questions, you guys can let me know. But just as a hint, the first thing I want to do is write down my givens and update my picture. So give that a shot. And if you guys have questions, let me know if you get stuck. Okay, and I would hope that since this is a proof that we don't write out our answers to everyone. So if you have something you want to send to me privately, we can do that, or else it kind of ruins it for everyone else. And while you guys are doing yours, I'm going to fill in my givens to help speed this up. All right. let's see where you guys got with this. Okay. So again, the first thing that you're always going to do is just copy and paste your givens down. But what we really need is our diagram. Our diagram needs to be filled out. So it says segment AC is congruent to segment EC. So I'm going to put a little tick mark to show that. And it says segment BC is congruent to segment DC. Okay, like that. And the reason why I'm doing this, right, is I have a pair of sides here and I have a pair of sides here, right? So if we're taking a look at what I can possibly do, I have two pairs of sides, right? So if I was looking at this, the easiest way to prove these would probably be one of these two, right? Because these only have one side, so one side would be wasted. So I'm either looking for another pair of sides or I'm looking for another pair of angles, right? So again, at the very beginning of this trimester, we wrote down all the possible angle rules. Okay, so what we want to be able to do then is find which one we're doing. So the first thing I look, well, if we're doing sides, right, there's not a lot of ways to do sides. So there's no definition of a midpoint, there's no bisector, they don't share a side, right? Those are really the only ways that we can get sides. So I'm going to say I'm going to look for angles. Well, what's always in a bow tie problem, right, is this X in the middle. And we have to remember, whenever we have things crossed like that, opposite angles are going to be congruent. Okay, so we're going to have here, I'm going to say, now we have to name this angle, right? We can't call it angle C because there's a whole bunch of angle C's. So we use the three-letter system. So we start with a leg. So we might say A, C, B, or B, C, A, right? So I'm going to go A, C, B. And then once you get that first one, we can use this statement here to get the second one. So for example, A is the first letter, that goes with E. C is the third letter, that goes with C. B is the second letter, that goes with D. Okay, so I know these two angles are going to be congruent, and my reason is going to be vertical angles. Right, so every statement I'm justifying with a reason. All right, so let's see here. So I have vertical angles. So I'm going to add in, I got A here and A here. So now I'm taking a look like, so I got that extra angle in here. And just to double check, do you see how in SAS, the angle's touching both sides? So I look here, the angle is in fact touching both sides. So I am able to finish this proof and say triangle ABC is congruent to triangle EDC, and I'm just copying it from what they said here, and then my reason is going to be SAS. Okay, like that. And does anybody have questions about that? And again, this is a proof that we've kind of saw before spring break, and it's a little rusty, right, because it's been a week. But does anybody have questions about the process or steps or anything that I did? Okay, and I appreciate the people giving me feedback. I really appreciate it because it helps me know where you guys are and what we need and what more practice we need. Ooh, with an explanation point. I like that. All right. Ooh, probably don't need to flip 2 pages. Just let's keep going then. So for this next one, I always like to think of this as a box that got hit. And now it's at an angle. So we're going to have A, B, C, and D with a diagonal connecting D to B. Okay. We're going to have 2 givens. It's like a pattern here. So we're going to have, for our given, we're going to have segment AD is congruent to segment CB. And we're going to have segment AB is congruent to segment CD. And what we're going to prove is we're going to prove that triangle ABD is congruent to triangle CDB. Okay, and I'm going to do the exact same thing that we did last time. I'm going to give you guys 3 minutes to work on this, because this is about a 3-minute proof. 3 minutes or less proof. Okay, so let me put that timer up. And I can write down, remember we have 4 shortcuts. So then we're going to go ahead and do this, right? So if you guys need the shortcuts again, I can do that for you. Okay, I'm going to hit start. There we go. So you guys got 3 minutes, and if you have questions, go ahead and send me a private chat or turn on your mic and ask as well. All right, so that was 3 minutes. Let's see what we can get with this proof. And I appreciate the people asking me questions and clarifying things. Good stuff, guys. So again, I'm going to always start by taking my givens and just copying them down into my proof, right? So I have segment AD is congruent to segment CB. I have segment AB is congruent to segment CD. So I have given. I have given. Okay. Then I'm going to update these in my diagram. So AD is going to be congruent to CB, and AB is going to be congruent to CD. Okay. And you can pick whatever tick marks you want, but you're picking them to be different because you don't know they're all the same, right? Just that the opposite ones are the same. Now, what I have here is I have 2 pair congruent sides. So again, I'm looking at these first two, right? So I'm either looking for a pair of sides or a pair of angles. Okay. So I always look for sides first because I think sides are the easiest to find. So there's no midpoint, there's no bisector. Do they share a side? Ah, they share a side, don't they? They share this side in the middle, right? So right there, right, this is going to be reflexive property. So I'm going to have, hey, segment DB. Now let's check here. What does D go with? D goes with B. So I'm going to have to switch it up here. So we have BD and DB, right? Do you guys see how B goes with D and D goes with B? And I'm going to have reflexive property, right? So that's the reflexive property. We used that a lot before spring break, right? So it shows up a lot, property, right? If we can get one side that is the same, and we know because we line them up, then we can get the other sides. It's actually a trick to do that in real life. So then in this case, if I take a look, I have SSS, so right here. So I can go ahead now, and I can say, hey, triangle ABD must be congruent to triangle CDB because I have SSS. Okay, just like that. So are you guys doing okay with that? Does anybody have questions or comments? All right. Well, let's go ahead then and take a look at our next one. So again, we're doing 5 proofs today. So we're just rocking right through this, guys. And again, if you guys have questions or comments or you're feeling stuck, it's normal to get stuck. It's normal to make mistakes or to get stuck. But what we need to do is figure out where we're getting stuck, why we're getting stuck, and then go from there, right? We want to get unstuck. We don't want to get stuck. We want to figure out what's causing it and to get unstuck. All right. Okay. So next up, we're going to revisit the bow tie problem. Again, just a representation, so don't worry if it doesn't look great. Like mine doesn't look super great, does it? But that's okay. A, B, C, D, and E. Okay, and then I'm going to have a couple of givens. So for my given, I'm going to have segment AB is congruent to segment DE. Now remember, congruent means same size, same shape. And then I'm going to have segment AB is also parallel to segment DE. Okay, remember parallel just means that they don't cross. They will never cross. And what we're going to do is we're going to prove triangle ABC is congruent to triangle DEC. Now, a little hint here that I would give to people, and you're people, so I'm going to give you a hint, is that whenever the proof has parallel lines in it, then right there you guys should be like, oh my gosh, don't we have a bunch of properties, 4 of them, that say if parallel then, right? So boom, right here it says these 2 are parallel. So in your notes, we should be thinking if parallel then, and then there's 4 of those. So it's just a matter of figuring out, okay, if I have parallel lines, what can I do with them, right? So again, whenever you see a problem has parallel lines, you think to yourself, man, I have 4 of those rules that say if parallel lines, right? So that's something you should be looking for here. So let's write down our givens, update our picture, and the given always gives hints, right? And the hint is, hey, we have parallel lines. We're going to be using that. Just another reminder, this problem, guys, there's 2 ways to do this problem. So there's 2 ways to do this problem and 2 correct ways. So lots of freedom here. So you got 3 minutes. Let's see what you guys can do. All right, well, that was 3 minutes, so I'm going to go ahead and take a look at what we got. So like I said, the first thing I'm going to do is I'm going to write down my given. So I'm just writing down my 2 givens. Okay, and then I'm going to update my picture. So it says AB is congruent to DE, and then that they're parallel. So I'm going to put this little arrow, and they don't look parallel, do they? So just remember, it's not about the picture. The picture is just there to help you out. Okay, so we have our 2 givens, and we have the congruency and the arrows. Okay, so again, I gave us a hint about the parallel lines, right? So like whenever you see parallel lines, then you're looking for angles, right? We're looking for if parallel lines then. So what are we going to use here? Well, we got on our parallel lines, we have 2 angles that are touching the parallel lines, right? So if I look at B, right, that is connected to E. And if I look at A, that is connected to D, right? So what do you guys think? Is there a relationship between those? I mean, if you guess, there's well, it can't be, right? So it's got to be on the inside, so it can't be exterior, right? And we want them to be congruent, so it can't be consecutive interior. So really, it's a 50-50 guess. It's got to be corresponding or alternate interior. What do you guys think? Right? And all of this is in your guys' notes, right? From that first class of the trimester. Yeah, it's going to be alternate interior. And this is where guys, this is where it's going to be up to you and how you want to do it, right? Because it actually turns out we have 2 pairs of alternate interior, right? We have angle B would be alternate interior with angle E, right? But wouldn't angle A also be alternate interior with angle D, right? So I'm just going to go ahead and write down this first one, right? So angle B is being congruent with angle E, and we can just use one letter, right? Because there's only one angle there. So we can use that shortcut. And then for my reason, I'm going to write if parallel lines, then alternate interior angles are congruent. Sorry, I got a little shorthand going there. Turn off that. It's getting in the way. Okay. So I have alternate interior. Yeah. And again, guys, like all of this stuff is open notes, right? So remember that we have those in there. So alternate interior, so it alternates sides of the transversal. You see how this one's on the bottom of the transversal, this one's on the top of the transversal. Okay. So we could go again and go A and D, right? And if we did that, we would have angle, side, angle, right? So that's one way to do it. So if we did A and D, that would be angle, side, angle. But I want to give out some love to all my homies who saw the vertical angles, so I'm going to do that instead. And it doesn't matter the order. If you, right, so anything in blue, it doesn't matter the order. So you could have done alternate interior first, you could have done it second, you could have done it twice. So let's see here. I'm going to go angle ACB is congruent. It looks like A goes with D, C goes with C, and B goes with E. Okay, so then I'm going to say here I have vertical angles. Now, if you did it this way, so again, like I'm trying to say, there's more than one way of doing it. You could have done angle, side, angle, but in this one, right, if we look at these, SSS, SAS, ASA, AAS, so we have 2 pairs of angles, but we got to see which one is it. Is the side in the middle or is the side on the outside? So all you have to do that, see how this side only touches one angle. See how this side only touches one of the angles. And so this one right here, the S, only touches one of the angles. So that means this is what we want. So again, just take a look. So this side only touches one of the angles. This S only is next to one of the angles. So I'm going to use that to finish up my proof. So I'm going to say triangle ABC is congruent
to triangle DEC. And what can I use here? I can use AAS, like that. Okay. So again, parallel line stuff, guys, we got to remember that. So that's something that you worked on in Geometry A. And we also took notes on that at the very start of this trimester. Okay? So got to know that stuff. Got to know those angle properties. Does anybody have questions or comments or concerns? This is we're going a lot faster because I don't have anybody asking questions like my other class did, which is fine if you guys don't have questions. It's just not fine if we do have questions, you know. All right, so gonna move on. I got 2 more proofs that we're gonna do. We got plenty of time. All right, we're gonna do a little different shape here. Oh, I did a really terrible job. All right, well, don't believe. We're gonna show that these are the same. They sure don't look the same in my picture. Maybe you guys can do a better job of that. Okay, so remember the picture again is just here for reference. It's not there to be accurate. So I have this shape. I have A, B, C, D. Given that angle BAC is congruent to angle DAC. Okay, so angle BAC is congruent to angle DAC, and that angle DCA is congruent to angle BCA. So angle DCA is congruent to angle BCA. We are going to prove angle D is congruent to angle B. Okay, so now I'm going to stop here for a second before we move on. Notice how I didn't say prove triangle blank is congruent to triangle blank. So then the first thing we should be thinking is, what kind of problem is this, right? So if we're not proving triangles congruent, what the heck is going on, right? So we have to remember back to our original here. So what is CPCTC, right? If the triangles are congruent, then all corresponding parts are congruent. So what always comes first? Proving triangles congruent. So even though it doesn't say prove triangles congruent, what are we going to do? We're going to prove triangles congruent. Because if these 2 triangles are congruent, then these 2 angles have to be congruent. So I hope that logic makes sense to you guys, right? So we're going to try to prove these 2 triangles congruent, because then these 2 angles have to be congruent by CPCTC. So you already know the ending, right? It's just a matter of, why are these triangles congruent? Okay. Does anybody have questions about that before I fill out the rest of this? So again, it doesn't say that we're proving triangles congruent, but we are going to prove triangles congruent, because if these triangles are congruent, then these angles have to be congruent. Okay. So that's what we're doing here. So it's just like the other problems. So if you were like, Kreft, I didn't get the other problems, here's your chance to get one right. Okay. You guys can do it. I know you can. Okay, so I'm going to give you guys 3 minutes. So again, write down your givens, update your diagram. How do we prove the triangles congruent? And then if the triangles are congruent, angle D and angle B have to be congruent, right? By CPCTC. So let's go ahead and give this a try. All right. So let's take a look at this problem. The first thing I'm going to do is I'm going to write down my givens, right? Because that's not really even starting the problem. That's just setting it up. And B, C, A. So I got my reasons are given and given, right? Okay. So I'm going to update my picture with these things. So BAC. So I start at BAC. So that's this angle right here, right? BAC. So BAC. And that's congruent to DAC. So that's this one right here. So DAC. So again, when you're saying the letters, just outline it with your pencil and you're drawing the angle, right? So that's the angle we're looking at. So then I have DCA, so DCA, so this angle right here, I'm just going to use a different marking, and then BCA, BCA, so these two angles. Okay, so I have a pair of angles here and a pair of angles here. So if I was just trying to take a look at this, I'm probably going to be doing one of these, right? Because I have two pairs of angles. And so what I'm really looking for here is a pair of sides, right? So when I'm looking for a pair of sides, I'm going to first look in my thing. It doesn't say I have a midpoint. It doesn't say there's a bisector. Okay, so the next thing I'm going to look for is, do they share a side? And if I look at this top triangle and this bottom triangle, they do share a side. They share this side in the middle. So I'm going to be able to say, right? Now, to see, right, if I write down segment AC, I can take a look at up here. It looks like AC goes with AC, right? So just, or CA goes with CA. So I chose AC, so I'm going to go like this. Okay, so segment AC is congruent to segment AC. And then, what's that reason, right? That's reflexive property. Okay, so hopefully you guys are getting comfortable with reflexive property, right? Because we've been using it in most our proofs, right? Either reflexive or vertical angles or alternate interior. Okay, so the side touches both angles, right? So the side touches this angle, this side touches this angle, and same with this one. So it looks like the side is in the middle. So I'm going to be able to say, next, I'm going to be able to say triangle, and I'm just going to use one of the already pre-made ones that was given. So how about DCA is congruent to triangle BCA, and then my reason is ASA. Now normally we would be done with the proof at this point, right? Because that's what we were doing before. But we have to remember that in this problem, angle D is congruent to angle B is where we're going to want to go. So we've proven the triangles are congruent, right? This triangle is congruent to this triangle. So then these angles have to be congruent. It's kind of like how you guys go shopping. Once you identify two things are the same, you don't need to go through every detail. You're just like, hey, these two shapes are the same, so these two angles have to be the same. And the mathy way of saying that is CP, CTC. Okay, and that's the proof. So again, if it doesn't say, hey, prove these triangles are congruent, you're always proving triangles are congruent. Okay? We're always proving triangles are congruent. All right, we got one more. We can squeeze in one more. So here's our last one. We're going to do another bow tie problem. I'm not going to be very original with my lettering. So I have A, B, C, D, and E. But my givens are going to change. Okay, my givens are going to change. So segment AC is going to be congruent to segment EC. And segment, oops, oh my gosh, this is totally not the proof I wanted to do. Scratch it, scratch it. We've already done that proof. Okay, so let's try this again. So I'm going to say I have let's do, and I know you guys, we've done one like this, but this is the proof I meant to do. Let's do A, B, C, and D. But the givens are going to be a little bit different here. So given, we're going to have segment AD is congruent to segment CB. And we're going to have segment AD is parallel to segment CB. So very similar startup, but a different proof. And we're going to prove that angle A is congruent to angle C. Now I don't have a lot of time, so I'm just going to start the timer right now. All right, so let's go over this. I'm sorry, I will go over a little bit. Don't leave though, because I have two really big important announcements at the end of class. So don't take off until after we have finished, okay? So the first thing I'm going to notice is I have a pair of sides. I have parallel lines, so the angle has to be touching the parallel side and has to be touching the, or has to be connected. So I'm going to say, hey, angle ADB is going to be congruent to angle CBD. And why is that? If parallel lines, then alternate interior angles are congruent. Okay, so I got a pair of angles here. And then I also see that they share a side. So again, the order doesn't matter here. So if you did this first, it's not a big deal. Again, order doesn't matter there. So let's see, D goes with B. So D goes with B. So this would be BD. So then I would say reflexive property. So then what do I have here? I have SAS, SAS. So I can say, hey, both of these triangles. So triangle, let's say I go DAB, because then I can get a dab joke in there. And then triangle BCD. And my reason is SAS. And then the last thing I'm going to say, hey, if the triangles are congruent, then the angles are congruent. So this would be CPCTC. Okay, as you're getting that down, I just have a couple of really important announcements. So it's come to my attention that a large majority of you guys don't have a lot of homework done. So what I've decided to do is, instead of doing a homework assignment tonight, you just have more time to do missing work. So make sure you guys get on Skyward, see what work you're missing, go into Big Ideas, and get that done. Remember, you have to click on your name in Big Ideas and hit Submit when you're done, or else it doesn't turn it in. It doesn't automatically turn it in for you. Okay, so no homework tonight. You guys just have extra time to work on missing assignments. Next thing, our next class is slated for this Friday. As your other teachers might have said, there's no in-person class on Friday, and that you're gonna have work to do. You're gonna have asynchronous work to do. So the way that I'm gonna do that is I'm going to be here at this time from 9 to 9:50. I'm going to have a lesson. I'm going to videotape it. I am not going to be taking attendance. So if you guys want to be here on Friday and be in class, you can, but I will not be taking attendance on Friday. But I will be posting the video online, and there will be homework for that day. Okay? So I just really want to make sure you guys understood that. If you guys have questions, you guys can ask questions. If not, then you are free to leave. Take care, guys, and I'll see you next